right, let's start today with probability identity. So we're going to start with a simple example, okay, but it's going to involve identities as we get to the end. All right, so the example here says, a survey was conducted amongst learners in grade 10 concerning their favorite colors. The results are shown in the Venn diagram. Okay, R is blue, R is red, B is blue. Okay, now the first question there, ooh, and we have our first spammer. Where's class one? Oh, class monitors in the other class. DeAndre, I'm watching you. Teacher Nels, if you could help Watobe, please. She can't see my screen. Okay. Hello, DeAndre. Asanda, finance starts next week. Okay. All right. So the first question says here, how many learners took part in the survey? Okay. DeAndre, you need to check your settings, please. Something's going on with your with either your computer or your device, because you are spamming us like crazy at the moment, my sweetie. Okay, double check what's going on, because that doesn't look like you. Okay, can you see what's up, my sweetie? Hello? Oh no, can you see it? You need to check your mic settings for me, please. I can't hear a single thing at the moment, so I just need you to check your mic settings to make sure that sound actually comes out. Okay, all right. How many students took part in the survey? I see Jessica saying 89 students. How are we going to find that 89? It needs to be 63 plus 28 plus 19 plus 42. And all of that together must give us 89. It should not be, it should be way more than 89, I think. I'm seeing 105. Or did you guys forget about the 63 sitting here on the outside? I have a feeling all of you guys forgot about the 63 sitting on the outside. That means that those people don't like red or blue as a color, correct? It's 152, right? So our sample space is 152 students, right? Okay, our next question says, how many learners like red? Now, I need you to be very careful. It says, how many learners like red? Now, it doesn't mean that they don't like blue either. They can like red and blue. So if we want to figure out who likes red, we need to look at the whole red circle. So this whole circle here, right, is 47, correct. That's 47 students. All right, now it says, how many learners like a color other than red or green? So how many students don't like red and don't like green? Correct, that's 63. They like a color that is not red or blue, so that is 63. All right, next one says, how many learners like red or blue? So it doesn't matter whether you like one, guys, remember, this section is for red and blue. This is when they like red and blue. Now, red or blue says that you can like either of them or you can like them both. There is no limit to whether you are red or blue or both. So remember, or, yes, Slay Queen, hello, Slay Queen. Or is going to be the whole of red or the whole of blue. Hi, Slay Queen.
Hi.
How you doing?
I'm good, and you?
Thank you. Were you going to answer my question, or was this just like the queen is in the house type vibe?
The queen is in the house, and also, yeah. Remember the question I was asking you about? Like the one where you'd have like one circle and then like one circle in the middle, but like intertwined with like the left one and the right one. Like that, like all three of them would connect except for the left and the right one.
Okay, so let me just see if I'm getting this correct. Sure, that's a huge circle. Okay, so something like this, and then we would have something like that. And then the third one doesn't touch both, it only touches the one. Is that what you're saying?
Wait, I'm just waiting for you to drop before I confirm.
Okay, so something like that.
Yes, ma'am. So you remember this one?
Okay, so the one I remember is when all three of them kind of intersect and we have like a middle.
No,
Duty.
not that one. Not that one.
No,
You said
okay.
that we would be
Something
doing,
like
you said
that.
that we'd be doing this one, the one that you just fixed now in university, right?
Yes, so we hardly ever get these kinds of things unless your teacher's giving you something like this, and I don't understand what they're getting at.
Yeah, counter off, son. Because yay, today was a mess. Today was a Mazda. Yo.
Okay, hopefully we'll clear up some misunderstandings. But as far as I know, we don't really do Venn diagrams that look like that. Funny enough, I've never even seen one in my life. Teacher Nelly, have you ever seen such a Venn diagram?
No.
No. Yeah. Normally when we have those, the two overlap or the three overlap, all three of them overlap. I've never had a situation where only two of them.
Yeah, there'll always be an intersection.
Yeah, for sure.
I cried over my book today. It was not healthy.
Yo, I'm sorry.
Like
I'm so sorry. Maybe it was just like a printing. I'm hoping it's a printing error. Maybe it was just a printing error. Let's hope.
It wasn't. Like there was a whole formula to it and everything. Yo, I was so scared.
Okay.
Yo,
all
and
right.
she was
Well,
like, it's gonna be exams. And I was like, so.
Okay, it might have something to do with mutual exclusivity, but we'll see in just a little bit. Okay.
Sure. Thank you so much.
All right, my sweetie. You're very welcome. Okay. All right. So now we're going to be calculating for the probability, guys. Okay, my mind is also frazzled now. Whew, Slay Queen, your questions sent me on a tangent. So now I have to bring myself back. Oh, okay. Yes, we're calculating probability. Now, let's look at the formula for probability. Remember, guys, the probability of any event is going to be the number of outcomes of that event over the number of outcomes in the whole sample space. Okay, and this says, ma'am, how is it 89 if you take 28 plus 19 plus 42? We should get 89, because remember, it's red or blue. Sure, Matavela is writing a maths exam next week, so is Alexander, guys. Oh, Alexander's in 2 weeks, but still. Good luck, guys. Fingers crossed. Okay, we'll wish you luck closer to the time. Okay. All right. So now it says here, calculate the probability that a grade 10 learner chosen at random likes only red. Let's talk about only red. How many students like only red? Okay, good. Only red is 28, correct. So just these ones. The ones we don't count these guys in the middle, because these guys in the middle like red and blue. So we're not going to count them. But remember, guys, we want the probability. So it must be something over something, right? So we know we've got the probability of only red, and that should be 28 over 152. Okay. So we need to write it as a full fraction, okay? And simplify the fraction. Thank you, Kanyisile. I was too lazy to take out my calculator, but thank you, 7 over 38. Thank you for that. Okay, Kanyisile, can you unmute now? Oh no, she's gone. Faye. Hi, my sweetie.
Ma'am,
how are you doing?
I'm fine. How are you, ma'am?
Good, thank you. What's up?
Ma'am, I wanted to ask on B, why did you write 47, ma'am? 47.
47 learners like red. Okay, so if we map out the red circle, how many kids like red in the red circle?
In the red circle, Wait one second. 47.
Yes, 47, because it's 28 and 19. Those are the kids who like red. Okay, that's why it's 47.
Oh, okay, ma'am.
Okay.
Thank you. Thank you,
All right.
ma'am.
You're very welcome, my sweetie. Good question. I'm glad we're not leaving it unsaid. Kanyisile, are you there?
Yes, hi, ma'am.
Yay, I can hear Kanyisile. Hello.
Oh my gosh, ma'am. Like every time I've tried to join this past 2 weeks, it was just load shedding. Like it's been
no, we need to write to Papa Sero. This is not right. It's not right. It's not. But I'm so glad to hear your voice. Yeah, it's lovely to hear your voice, my sweetie. Okay, do you want to answer this next question for me?
Yes, please,
Okay.
ma'am.
Yes, I'm looking for the probability of that one of the learners chosen at random likes red and blue. What do we know about this word and? Can you see it?
That they both like the red and the blue, and that's 19
Correct.
students.
So, correct, that's 19 students. Do you remember what we call this section here in the middle when we're talking about probability? Do you remember what it's called? There's a fancy name for it.
Oh, ma'am, I forgot.
It starts with an I. It starts with an I.
They intersect.
That's it. Beautiful. It's the intersection. So we're looking for the probability of red intersection with blue, and you're 100% correct. It is 19 over 152. But you need to simplify, my sweetie. You can't leave it.
Yes, ma'am. It's
You can't
when I
leave
it says it's 1/8, and then when I converted it to percentage, it said it's 12.5%.
12.5%, or I'm going to write it as 0.125. Is that okay?
Yes, ma'am.
I'm going to leave it as a decimal. I prefer decimals. Even if you put it as a percentage, it's not wrong. It's just my OCD is going to kick in, and I don't know. Okay, decimals work for me. All right. Okay, I want you to do the last one with me as well, because you're doing so great at these. Okay, let's do, what is the probability that a learner chosen at random does not like red? And there's also another fancy word for not in mathematics. What do we call it? The probability of red what? Do you remember what the word is? Oh, Keegan's reminding me in the chat.
Complement.
It's the complement, yes. I like how everybody's writing it with an I, as in they're complimenting you, but it's actually complement with an E, with 2 E's, but that's it. Yes, they are complimenting your stellar mathematics skills, Kanyisile. I see them. Okay, so what is the probability that one of the kids chosen does not like red at all? How many students don't like red?
It's when I calculated it at 105.
Correct. Do you know how we got that 105 though?
Yes, we added the 63 with the 28. No, with the 42.
With the 42, correct. Okay, why do we not include these dudes over here? Can you see? Why do we not include 19?
Because they like both red and blue.
Correct. And we can't take anybody who likes red just because they like blue. And if they like red, then we do not include them. I love Mawande says they are red affiliated, which is such a nice one. All right, so our fraction is 105 over 152. Now, can you still need to give it to me as either a decimal or as a fraction, please?
As a decimal, it just gave me the same thing, so I just converted it to a percentage. Because in my class, they said we convert it to a percentage, so it's 69.07%.
69,07%. Okay. Now, if we had to have that as a decimal, we just say 0.691, because the 7 would turn the 0 into a 1. But Kanyisile, I mean, you did the things. You did the damn thing. Well done. So nicely done. Beautifully done. Guys, be a Kanyisile. Be a Kanyisile, guys. I want to hear your voices. Put your hands up, answer questions, ask questions. Yes, can you, Keegan, be a Kanyisile in terms of marks, in terms of, you know, confidence, all of it. She knows the things. She knows the things. Siamtanda, what's up, my sweetie?
Ma'am, I wanted to ask a quick question regarding the unions and the intersections. So is it true that when we say intersection, we can also say and? And is it true that when we say union, we can also say or?
Correct. Okay, so if you look at the question we've just done here, okay, if you look at the questions we've just done here, look over here. Do you see how we said that we're looking for students who like red and blue? And you'll see that Teacher Coco strategically used the symbol for intersection there instead of writing and. You see that?
Oh, yes, ma'am.
Mm-hmm.
Then we can also
so
use
they
that
kind
for
of
union.
they go together. Okay, so if we wanted to say red or blue, we can say we want the probability of red union with blue. Okay, and if we say red and blue, that's the probability of red's intersection with blue. Okay, and that's how we write it. You're very welcome. Good question. Good question. Make sure everybody's on the same page with us. Jessica, what's up, my sweetie? It's a while since I've heard your voice.
Hi, ma'am.
Hello.
Ma'am, when you write, it's going very good, ma'am. Just busy. Ma'am, when you do in the quiz, ma'am, it was difficult. I didn't understand a thing. Ma'am, when you do the brackets and it's very confusing.
Okay, when we do the brackets here, these brackets.
Yes.
Okay, so this is just basically, the brackets just tell us what the probability that we're doing is for. Okay, so I think what I will do, Jessica, is as we are doing the next few questions, I will slowly try and explain to you exactly what it is that we're doing, okay? And what the bracket means as we go along, so I don't lose you. I don't want to leave you behind, okay, Masudi?
Because my maths, I didn't start the Venn diagram, so it's a head start just to know what's going on.
Okay, that's fine. Yeah, that's yeah. I want you to take in as much as you can, okay? But if it's going to confuse you, okay, I want you to just listen, okay? Because your teacher at school is going to then do it again, and it'll be a little bit easier. Okay, so if you start feeling yourself getting confused, just be like, you know what? Today I'm going to Netflix and chill. Okay, I'm going to chill today and watch. Just so this is the one time you're allowed to just chill and watch Teacher Coco do maths. Okay, if you feel like
ma'am, I'm going to help because I love to help ma'am with the maths.
I love to hear it. Oh, a woman after my own heart. I love it. Thank you so much, my sweetie. Okay, all right, hang in there. I'm going to try and go a little bit slower. Okay.
Okay, ma'am.
All right,
thank you.
Sweetie. You're very welcome. Mawande, what's up?
Hi, ma'am. How are you?
I'm good, thank you. How are you?
I'm good, ma'am. So, ma'am, for the last question, for question E2, right? Should it be? Should we leave it as percentages or as decimals like that?
All of them are correct. All of them. Whether you leave it as a fraction or a decimal or a percentage, all of them are correct. All of them are considered correct.
All right, understood. Thank you.
Okay. All right. Good question. Good question. Guys, choose for yourself whether you want it as a fraction, a decimal, or a percentage. Anotita. Oh my goodness. Teacher Nels, when was the last time we heard Anotita's voice? I mean,
no, last week.
Even alive?
Tomorrow he's supposed to be to do the rules. So we heard his voice last week.
You've been running away from it. How are you doing, Anotita?
I'm doing good. How are you?
Oh, good. Thank you. Good. Very good. Thanks. What's up?
All right. I wanted to ask you a question. I heard that a previous person just asked if we should leave it in percentage or a decimal form or fraction form. Now,
okay.
In the quiz, it always asks us to leave it in a decimal form. I wonder why. Because I left it in a fraction form. Marks.
Okay, you know what it is? I think it's because when you get to the older grades, they hardly ever put it as a percentage. Okay, I've only ever seen it as a fraction or as a decimal, mainly decimals actually. I hardly ever see it as fractions as often. So I think it's just a way of getting you used to it. Okay, because normally by the time you get to matric, all I see is decimals. That's all we ever mark, decimals, to be honest. Okay, so yeah, maybe just get used to it as we go. It's something that is going to happen quite often. All right.
What's our next question?
It's not a question. It's an explanation. The question comes next. Okay.
Let me just chill for now. Let me just chill.
Yes. Okay. Chill while I explain, and then we can get back into it. Okay. All right. So today, peeps, we're going to learn 2 rules. Okay. These are the rules for and or. Okay. I'm going to sugarcoat it a little bit for the sake of time because I don't want to confuse you guys. So we're going to learn 2 rules. We're going to learn about the addition rule. And the addition rule refers to the probabilities of all. Okay. The addition rule refers to the probabilities of all. And then we are going to learn about the multiplication rule. And we're not going to learn this dependent one because this one is going to confuse you guys. We are going to learn about the multiplication rule for independent events, and that's for and. Okay, that's when we have and, A and B, when we're going to use A and B. Now, I want you guys to write both of these formulas down. Okay, this first one over here is called the addition rule. And the one down here is called the product rule. I keep saying the multiplication rule. It's called the product rule. Okay. I'm going to give one last warning about the chat. We're going to switch it off if it continues. Okay. All right. Give me a thumbs up in the chat after you've written down the 2 rules, and then we'll get started on today's lesson. Okay, I'm going to show you how we work these lovely rules, how we put them together in whatever it is that we are doing. Okay, excelente. Let's get into it. Hi, Maya. Woo, Maya's a whole half hour late, but it's fine, Maya. We're just glad you came to join us. A mental thumbs up. Thanks, Princess. Okay, all right. Okay, we're not gonna do conditional probability, otherwise it's going to confuse everybody. Okay, we don't want to do that. All right, let's look at the idea behind the product rule and the addition rule very quickly. Okay. Mawande, wait, why are we waiting? Why are we waiting? Guys, come on, 5 seconds. 4, 3, 2, 1. Okay, done. Okay, good. All right. Leave the others. Thanks, Mawande. You're such a friend. Such a good, loyal friend. Okay, let's just have a look at this question over here very quickly. And then we're going to come back to what it means to be dependent and independent and how we calculate for each of these. Now, the definition that I've written over here says 2 successive events are dependent. Now, I want you guys to note that when we talk about dependence and independence, there's always more than one event. More than one event. Okay. What that tells me is that something is going to happen and then something else is going to happen. So two things are going to happen one after the other. And that's what successive means. Amogelang already looks like, you deaf to English. Don't stress. Successive just means one after the other. Okay, so two successive events are dependent if the outcomes of the first event have an influence on the outcomes of the second event. Let me give you an example. Right, let's say I have a bag, and in this bag, there are 2, or let's make it 4 red sweets and 3 green sweets. Now, before I even take out a single sweet, what is the probability that I'll pull out a blue sweet? What is the probability that I'll pull out a blue sweet? Oh, Mamello, there are only 3 sweets, but you haven't given me the probability. Now, Jessica, watch what I've done here, just so that I don't lose you. Okay, these brackets tell me what I'm looking for the probability for. So I could easily write this as the probability of blue. Okay, I can do that. And I know that there are 3 sweets out of 7. Right, guys, this is event 1. Okay, event 1. Okay, Princess, it won't be 1 out of 7 because we have 3 blue sweets. Okay, so it has to be 3 out of the 7. Now, let's say, for instance, we actually put our hand inside the jar and we pull out a red sweet instead. Now, let's look at what happens with event 2. Let's think about event 2. Now, what is the probability that I'll pull out another blue sweet? Mind you, I ate the red sweet because I'm not in the business of putting sweets back. They must go in my mouth because we're eating sweets. So good. The probability after I pulled it out is 3/6. Now, if we take our calculator and we turn these probabilities into percentages, right? I just need to fix my thingy quickly. 3 divided by 7. This percentage over here of pulling out a blue sweet is 43%. The probability of pulling out a blue sweet there is 43%. The second I pull out a red sweet, my next probability then becomes 50%. Give me a thumbs up if you notice that the probability has now gone up. Do we see that? The probability has now gone up. Okay, so these 2 events are dependent events. They are dependent because the probability of the second one is dependent on what happened the first time. Okay. Yes, correct, Maya. Yes. Excellent. I'm glad everyone's with me. Slay Queen, what's up?
Hey girl. I had like a cute axe, ne, with an AX. Yeah. I had a cute axe. Sure. So ma'am,
okay. So what I'm doing right now is I'm sending you in. It says you are not here. I don't understand what's going on. I'm trying to send you a DM and it's not working.
Wait, girl.
It's not working and I don't understand how it's not working.
But I'm present.
Okay, okay, there we go. Okay, there you go. I've sent you my work email address. Do you want to send that picture to me there? And then I'm going to drop it onto the screen here and we'll have a chat about it. Okay, sure, does that work for you?
Yeah.
Okay.
Thank you so much. Right. But I was also going to say, so going back to like this example that we're on right now, I'm not even sure if we had moved on because like you lost me halfway through the explanation.
Oh my goodness, okay.
So ma'am, were you
Yes.
So you were explaining the P blue is equal to 3/7 if the probability of us picking up a blue sweet, right?
Yes, correct.
Something like that. And then if we did stick our hand in and then we pulled out a red sweet, then after that you explained the probability. Oh, the probability would be a half.
Correct. Okay, because
now,
I had two different events, right? Yes.
I got. So
okay, so
now,
if I take out the tweet and I don't put it back, the probability will become higher. Okay, because the chances now they're less red sweets, so the probability for me picking a blue one becomes bigger. Okay, it becomes greater. Is that making sense?
A little bit. You know, we suffer.
It's going to make a little bit more sense as we go through different examples. Okay.
Thank you so much. We are God's strongest warriors. Push, Amanda.
Oh, always a drama queen. All right, peeps. This is not an independent. This is a dependent event. Now let's think about this. Let's do an easy example for independent events. Right? I flip a coin. My coin only has two possible answers, right? A heads or a tails. What is the probability that I will throw a heads? Before I even throw, what's the probability? It's a half. Good. Everybody knows this. It's a half. Right. This is event one. Event one. Now, I flipped my coin and I found that my coin did, in fact, give me heads. Now, event two, I flip my coin again. What is the probability that I'll get heads? Keegan, don't. I see you. Good. It's also 1.5. Now, my question, easy question, yes or no? Did the probability for event 1 and event 2 change? No, they didn't. So my question here are these two events dependent or independent? Correct. They are independent because it doesn't matter what happened before. The probability of it happening again is still the same. Beautiful. All right. Independent. This is independent because it's not going to change. It's not going to change anything. Every time I flip the coin, 50-50. Every single time. Flip it 100 times, 50-50. 2,000 times, 50-50. The probability of the first event will not affect the probability of the second. All right, give me a thumbs up if the difference between dependent and independent events makes sense to you. Give me a thumbs up, peeps, because we're going to actually work with these and we want to make sure, okay, that we are doing the right thing. Beautiful. All right, let's start with this example that we have over here. Who said mid thumbs up? Okay. All right. Okay, let's read this question that they've given me over here. It's entry. Okay, let's look at this question. This question says, suppose there is a box that has 3 red marbles and 2 black marbles. We select 2 marbles. So before we even go there, let's think about the probabilities of event 1. Okay, let's think of event 1. What is the probability that we would pull out a red marble? What's the probability of a red marble, peeps? How many red marbles do we have, guys? Correct. Before my computer dies, I need to plug it in. Oh no. Okay, good. It's 3/5. What is the probability that I will pull out a black marble? Yes, Pamela. No, Pamela, don't go away. I want to hear your voice. Come back. Okay, good. So we know that the probability of a red marble is 3/5, and the probability of a black marble is 2/5. Now, let's look at event 2. Right, if we look at event 2, they say, what is the probability that the second marble is red, given that the first one is also red? Right, so we need to consider the probability of that one. What's going to happen the next time when if we've already pulled out a red marble? What's the probability that the next one will also be red in event 2? Now, think about this, guys. If I've removed one of the red marbles, I only have 2 of them left. But I've removed a red marble. So how many do we have left in total? If I've removed one, that's it, Buche, that's it, Mawande. Good stuff, peeps. Correct, 50%. There's only 4 of them left. 2 over 4. Because we've taken one sweet, now I'm saying sweets. See, this is what happens when you use food for examples. Okay, because we've taken one marble out. Okay, all right. And that is our example for dependence. We are not going to stress dependence too much because we can figure dependence out by figuring out what is independent. So we're not going to stress about that too much. Okay, let's look at an example of independence. Okay, it says here, a die is rolled twice. A die is rolled twice. If event A is the first roll, shows a 6. So if I roll my dice and it lands on 6, 1, 2, 3, 4, 5, 6, and event B is the second event, is the second roll, and it also shows a 6. Now, let's answer the first question. Are events A and B independent? Is it dependent or independent? And I want somebody to please put up their hands and explain to me, why is it independent? Sinako, yes. Sinako, why is it independent?
Ma'am, I had a network problem, ma'am. Can you please rephrase the dependent and independent?
Okay,
thingy?
so we are rolling a dice, right? The first time I roll my dice, I get a 6. And then I roll my dice again and I get a 6. What are these two events independent or dependent?
Yeah.
Okay. Are you not sure?
Yes, ma'am.
Okay. Can I ask Mawande to help us? Because I feel like he's got the answer for you, my dude. Okay. You see, he's even saying, let me cook, ma'am. He's got this. Mawande, okay, help us out. Why can we say independent?
Because the chances don't change, or like sample space doesn't change.
Beautiful. That's it. Because the probability of event 1 does not change the probability of event 2. I couldn't have put it better myself. Very well done. But Mawande, I'm not going to let you off the hook. You can't just go. Okay.
Okay.
So we know that this is dependent. It's independent, right? So we now have to find the probability of A and B. Now I'm going to ask Mawande, are we going to use the addition rule or are we going to use the product rule?
We are going to use the product rule.
Beautiful, beautiful. Now, I need you to remind me, what does the product rule says? It says that the probability of event A, intersection or union?
It's going to be intersection.
Correct. A intersection B is going to equal to the probability of A. What comes next?
Times B, times
Correct.
Probability of B.
Beautifully done. Okay, so fill in the blanks. What is the probability of event A? The probability of rolling a 6 on the first one.
So the probability of event A is going to be roll a 6 first.
Correct. 1 over 6, good. Times the probability of event B.
It's going to, events roll a 6, shows a 6. Or
correct. So it would be, what's the probability? If we're throwing a 6, what's the probability going to be?
2. Oh, no, I mean,
oh,
one,
it can't
one,
be
sorry,
2
one.
Correct, because it's a different event, right? So 1 over 6. So what is 1 over 6 times 1 over 6?
It's going to be 1 over 12. No.
Oh, no. Remember, we need to multiply. 1 times 1 is 1. 6 times 6?
It's going to be 1 over 36.
Beautifully done. 1 over 36. And that is the answer I was looking for. Mawande just drops mic. Poof, done. That's it.
Thank you.
That's exactly what I needed to do. Well done. Great
Thank you,
stuff.
ma'am.
Awesome, awesome, awesome. So we just need to remember to use the formula. Yes?
Yes, ma'am.
Love it. Okay, excellent. Keegan says, do we simplify? I know you weren't calling me a sim. Yes, we do simplify. We do simplify. All right, let's talk about mutual exclusivity quickly before we run out of time. Okay, so mutual English. Whew, guys, it's not my mother tongue, hey? All right, so mutually exclusive events. My goodness, mutually exclusive events are events that have nothing to do with each other. That's why we call them disjoint. We call them disjoint. Like, let's say, for instance, you have to choose between taking maths and taking maths lit. Okay. At your school, are you able to take both maths and maths lit? Oh, yes, Entle wants to explain it. Entle, you can put your hand up, my sweetie. Let's unmute you so you can explain to everybody mutual exclusivity. Yes, Entle.
Hello, ma'am.
Hi, my sweetie.
How are you?
I'm good, thank you. How are you? I'm good, thank you. How are you?
I'm good. So how we simplify it, how we explain it in a simpler way is that if you don't have, let me see, pages. If you don't have what's this? Common outcomes, that means your probability will be probability of A and B will equal to 0.
Beautiful. Good. Beautiful. Okay. Good. And I'm glad you explained that way. I'm just gonna mute you for a second because there's a bit of feedback. I'm glad you're explaining it that way. Thanks, Alicia. Because we need to understand it in terms of the calculations that we are doing. All right. So what Entle is saying is that if there are two things that are mutually exclusive, they can't happen at the same time. So the probabilities of the one and the other together must equal 0. Okay, so let me explain. Let us take this example that we have over here of this over here. We're going to call this M for maths and L for maths lit. Now, is there going to be any child in the middle here? Is there going to be any learner who can do maths and maths lit? No, not at all, not at all. Right, not at all. So what this tells me about my two circles is that my two circles can't actually touch each other. They're not supposed to, right? So if we then had to calculate for the probability of maths and maths lit, what would my answer be? Considering that they don't touch each other, what would the answer of the two of them together be? Entle, what should the probability of the two of them together give us?
It should be 0.
It's so weird to hear the echo on Entle's side because I'm hearing my own voice and I don't like the sound of it. Okay. And we're not. Yes, Keegan, when two events are mutually exclusive, the probability of them, the intersection of those two is equal to 0. Okay, it's equal to 0. All right. Oh, thank you, Mfundo. All right, let's put some of this stuff to use. Okay, I don't want us to just look at it and leave it where it is. Let's practice a little bit. All right, so I want you guys to look over here. The question says, if the probability of A, I'm going to name this part A, and I'm going to name this part B, right? It says the probability of A is 0,3. Now, I want you guys to remember that this is the whole of A. This is the whole of A, right? The probability of, excuse me, the probability of A needs to be 0,3. Now they say that the probability of B, of the whole of B, needs to be 0,5, 0,5, and the probability of A or B. So both of these put together must give me 0,7. But now here's the problem, guys. 0,3 and 0,5 gives us 0,7. What goes where? There's a particular number missing. How much is it that's missing that needs to go in the middle? What do we think? How much is going to go into the intersection? Correct. Correct. That's it, Keegan. That's it, Boucher. We know that in the intersection, we're going to get 0,1. Okay, Haibo, who's this now spamming us again? DeAndre, is that you? No, it's Babala this time. Okay, all right. Maybe I should, I don't know if I remember, I don't remember if I explained this, teacher Nels, but we did say, guys, that the probability of all events added together must equal 1. Correct? The probabilities of everything together must equal 1. So if we go back to those examples that we were doing, guys, if we go back to the examples that we were doing, we don't know what the intersection is. So we can call the intersection X. Okay, so that means this part over here would have to be 0,3 minus X. And this part over here will have to be 0,5 minus X, right? And they've just told us that these three all together must equal 0,7. Okay, so if we put our formula together, we're going to go 0,3 minus X plus 0,5 minus X is equal to 0,7. Give me an answer, guys. What are we going to get for X? Please calculate for me. Correct, Princess. Okay, solve for X. If we solve for X, negative X plus X will cancel. So I'll have negative X is equal to 0,7 minus 0,5 minus 0,3, right? And that's going to give me negative X is equal to negative 0,1. Therefore, X is equal to 0,1. Okay. And that's where we get the idea that this middle part over here must equal 0,1, right? But if 0,1 has already been taken, that means that B cannot be 0,5. How much is B going to be? If the whole of B needs to be 0,5, how much are we going to have over here? Correct, Mfundo. Refilwe, what's up?
Hi, ma'am.
Hello, my sweetie.
Oh, ma'am, can we go back to the last question? Because like I didn't understand like properly what's happening there.
Okay, hold on. In this top question over here.
Yes, ma'am.
Okay, can I come back to that in just a little bit? Because we are kind of running out of time a little bit. Okay, and I want us to be okay with this particular question and we'll come back to it. All right.
Okay. Yes, ma'am.
Okay, excellent. All right. What about this side over here, guys? Okay, this side over here says 0,3 minus X. So A then needs to equal, correct, Mfundo, 0,2. Good. Right. But remember, guys, the probability of the whole sample space must equal 1. So how much are we missing in the rectangle? How much are we missing in the rectangle? Not 0, Keegan. If this part over here, if all of these together make 0,7, how much is missing for us to get to 1? Correct. That's it, Abigail. Good, Keegan. We're looking for 0,3. Very nicely done. Okay, so these are the probabilities. So I want you guys to use the answers that you've got in this Venn diagram to answer the questions A, B, C, and D. And everybody's got 2 minutes because the lesson is about to end. Okay, Matebele, what's up?
Hello, ma'am.
Hello, my sweetie. What's going on?
I wanted to ask that, is it okay if I said PA and B is equals to PA plus PB minus PAOB?
Correct, because that is the addition rule. It is the prediction rule. But remember, the addition rule comes when we have an or in the middle, not an and. Okay, and means we must multiply. Right, and is the intersection, which means PA and B must be PA times the probability of B. Okay, it's a product
Thank
rule. Okay, the one that you've used is if there was an or in the middle.
Oh.
Okay. You're very welcome, my sweetie. You're very, very welcome. Keep it up. Keep it up. Anotita, what's up?
Wait, ma'am, should we answer these or should we just answer?
You need to answer that. And time is actually up because we're going to answer that. Okay.
Oh, okay. I already have the answers, but okay, it's fine.
Okay, cool. All right, let me see what's going on in Slay Queens. All right. Okay. I'm going to go through the answers really, really quickly, guys, because we are kind of out of time. Okay. So if we look at the probability of A and B, it's going to be this probability over here because that's the intersection. So the intersection of A and B, the probability of it is going to be 0.1, right? Then the probability of not A will be everything that is not A. So it needs to be 0.4 and 0.3. Okay, both of those together. The probability of not A is 1 minus 0.3, which should give us 0.7. Well done. All right, now it says, what is the probability of not A and B? Right, now, this is very tricky that it's been written. Yes.
Oh, for me, not A and B. Okay, so we're gonna say 0.4 plus 0.3.
Okay, make that make sense. Explain to me why.
Okay, so they said okay, not A and B. Oh, sorry, sorry. I just thought not A and B. So it's just gonna be 0.3 since it's the only one that's not a part of A and B.
I thought you would say that, but remember, not A and B means that part. It means that part. A and B means that part. Right.
Oh, okay.
A and is just the intersection. So everything that is not the intersection.
Yeah,
oh, yes, I do need to
go.
I do. Yeah. Okay, sorry. So the probability of this is going to be 1 minus 0.1, which is equal to 0.9. Okay, and then the probability of not A or B, this is where you were talking, Anutita. It'll be this whole thing. So the answer would just be 0.3. Okay, so the probability of that is equal to 0. Okay, I've got to run. Bye-bye, everybody. I will see everybody on Wednesday.